Hi everyone, good evening. Am I audible now?
Yes, sir.
Okay, so we can start with our vSphere storage concepts today. Today we are in the session 5. Uh, in our previous sessions, we discussed the vSphere storage concepts, basic concepts. We start with the local storage, fiber channel SAN, FCoE, and also we covered the iSCSI SAN and also the NFS storage. So today we are going to discuss the vSAN storage architecture and home lab. Let's observe our today's agenda. And it includes a vSphere storage overview. We can quickly run through our vSphere storage overview again, and we can observe the differences between our previous storages and the specifically for this virtual SAN. And also we need to understand the term, the new introducing the terminologies, software defined storage. We can try to understand the few key concepts in SDS, software defined storage, and then we can start with virtual SAN architecture. Within our virtual SAN architecture, there are some key concepts which includes vSAN components, vSAN hybrid versus all flash, and also the virtual SAN disk groups and virtual SAN hardware requirement. Before we configure the virtual SAN, what is the main hardware requirement? And also vSAN data store objects. What is the main data store objects in virtual SAN? And vSAN virtual machine storage policies. This is also one of the key concept in vSAN architecture. And finally, we can conclude with the virtual SAN use cases. Virtual SAN use cases, we have plenty of use cases. And also in our official VMware website, vSphere is separate course and the virtual SAN is a separate course, but separate course means it's completely a 30 hours session. But in this session, I will cover the main key concepts. Suppose if you're really interested to learn some more on the virtual SAN, once we end with the vSphere concepts, at the end of the session, we'll going to cover the remaining vSAN advanced concepts. Okay, and finally, we can do the vSAN data store creation and management in our lab. Okay. Let's start with the vSphere storage overview. So this is very familiar diagram now. Uh, you already aware that in our vSphere, it supports mainly for the 4 types of data stores. One is virtual machine file system, network file system, and the third one is virtual SAN. This is the one we are going to discuss today. Once we familiar with the vSAN, we can cover the virtual volumes. Okay. And ESXi host should be configured with shared access to data store. All these data stores are supported for a shared data store, except local hard disk. Except the local hard disk, the remaining all the data stores is supported for a shared access. So within our ESXi virtual disk, all the virtual machine consists of virtual disk. All virtual disks are stored in a data store. This data store type should be either VMFS, NFS, vSAN, and virtual volumes. And VMFS concept we are familiar now, and we have the default VMFS supported protocols. That is includes direct attach, which is DAS, direct attached storage, and it will support for the fiber channel SAN and the protocol name also fiber channel, and it will also supported for a FCoE, fiber channel over Ethernet, and it will also support for iSCSI SAN, and the protocol name is iSCSI, Internet SCSI. And when comes to the NFS, the protocol name also NFS, and it will connect through Ethernet connection. We can create a shared folders. But in the FCoE and iSCSI, this SAN terminology, if you want to store all your virtual machines, we can store only in the LUN. LUN means logical unit number. But today's session, before we start the vSAN, I just highlighted one key point here. Why in the real-time scenario, we have a fiber channel SAN, iSCSI SAN, and NAS. Why still we need to go for a software-defined storage, which is virtual SAN? There is some key capabilities to prefer the virtual SAN. So I'm trying to explain you what is the importance of virtual SAN. And this is also one of the interview question. They may ask why we need to prefer to use virtual SAN in the real-time scenario. Still, we have a NAS storage, SAN storage. Within the SAN, we have two types of SANs, fiber channel SAN, or we can use FCoE SAN, or you can use a iSCSI SAN. Even though we have a NAS boxes, SAN boxes, why we still prefer to choose the virtual SAN? One of the main differentiation for the virtual SAN is, if you observe the last line, whenever we plan to install the virtual machine on a direct attached storage, the initial stage itself, we need to configure our disk, local disk. That local disk, suppose I have one local disk, you can configure on a local one disk. If you have a two hard disk, we prefer to choose enable the RAID 1 on a hardware level. RAID 1 means it's a mirroring. In case of one hard disk is failed, we can restore the virtual machine from the another hard disk. But in the RAID, we can configure, it's only the initial stage itself we can configure a RAID 1. That means it is nothing but a predefined storage options. The similar case applicable for fiber channel SAN, iSCSI SAN, even the fiber channel SAN. When you purchase a storage box, as we know in our storage array, we have a n number of JBOD, just a bunch of disk. Using this just a bunch of disk, we can create a lunch. But in when we purchase the storage box, the initially it is a predefined storage option. That means when you purchase the storage box itself, we can ask our storage vendor, can you arrange for a RAID 1 storage sandbox, or can you arrange for RAID 5 sandbox, RAID 6 sandbox, or RAID 10 sandbox. So when you configure the RAID 10 in the initial stage itself, in our later stage, suppose my virtual machines, there is a requirement from the customer want to configure three virtual machine. One virtual machine, he don't want any of the RAID configuration, he want a normal virtual machine because it's a test VM. And the second one, it's a development VM, he want to configure a RAID 1 for the high performance and redundancy and security purpose. So, and the third virtual machine is production VM. That production VM customer recommend to choose either RAID 5 or they may recommend to choose RAID 10. During these three scenarios, if you have a sandbox with RAID 5 configured sandbox, or RAID 1 configured sandbox, or RAID 10 configured sandbox, when you want to meet your customer requirement, by default it's not possible, because our sandbox is already predefined, it's configured with a RAID 5 or it's configured with a RAID 10. When your customer requested for a multiple policy request, like one virtual machine I need RAID 5, one virtual machine I required a RAID 10, it's definitely it's not possible option when you are using a physical FC SAN, or it's applicable for other sandboxes also, like FCoE also it's applicable to iSCSI SAN also. But only difference is protocol different, but the storage box is still common. Can anyone tell me what is the difference in FC and iSCSI? In FC, do we require a normal switch or fiber channel switch for fiber channel storage?
FC switch.
We need a FC switch. Suppose when comes to the iSCSI SAN, do we require a FC switch or normal IP based switch?
Normally.
Normal IP based switch. Yeah, good. So, but only the connectivity is different, but still the storage box is common. It either a iSCSI storage or FC storage. It's always in the predefined storage options only. I given the example here: RAID 1, RAID 5, RAID 10. But during this scenario, if your customer requested for a multiple storage options, so definitely your storage box will not support. We need to procure a new storage box. Again, it's a cost, very high expensive cost. So during this scenario, what is the best option is, if you have a software defined storage, which is virtual SAN. Using the virtual SAN, we have a multiple storage policies options. You can configure a default vSAN storage policy is RAID 1, and you can also customize and create a multiple storage policies, which is RAID 5 and RAID 10. Suppose your customer requirement three virtual machines, he requested for three different policies. Even though if you do not have fiber channel or NFS, using the vSAN, we can define these three options. One virtual machine, you can set RAID 1, one virtual machine you can set RAID 5, and another third virtual machine you can set RAID 10. So that is the importance of virtual SAN. Why still the virtual SAN is become popular, and also the what is the benefit means, this is one of the main key benefit in virtual SAN. Okay, is it clear? That's why I highlighted that only from director attached to until the NFS, it's always predefined storage option. But if you want to overcome this one, we should go with a software defined storage, that is virtual SAN, in short form vSAN. And vSAN we configure directly on a local hard disk only, direct attached, and we doesn't require any external storage boxes. That is also importance of virtual SAN. That means our entire storage network cost is reduced. We no need any fiber channel switches, we no need to purchase a sandbox. But only thing is, whatever the ESX host you are procuring, that ESX host must include with a additional hard disk. Using that additional hard disk, we can make it as a virtual SAN. So today we are going to do the lab also, how we can prepare a virtual SAN without external storage box. Is it clear? Excuse me. So now we are going to observe the software defined storage concepts now. So try to familiar with this terminology, software defined storage, because nowadays everything is software defined. Even in our other session, we discussed about STDC. STDC means software defined data center. Within the software defined data center, the main key components are compute, network, storage. Compute means our vSphere is the one of the software defined compute platform, and the network, within our network, one of the software defined network platform is, it's a NSXT. It's also VMware product only. And when it comes to the storage, there is a plenty of third party vendors also preparing the software defined storage, but we are focusing on the VMware software defined storage, which is vSAN. And compared to the other third party vendors, VMware vSAN also most popular. It's always the rated in the top one or top two. It's always in the top one or top two stage only. Okay, so this is also one of the important concept to understand the software defined storage. I'm trying to brief you the some basic concepts in software defined storage. Suppose if you observe the right side diagram, in the center of the diagram, we have a data store, and this data store we divided into three options. One is data, another one is location, another one is protocol. Let's start with the protocol. We already know protocol is nothing but it's a kind of language. It's a set of rules. It's used to communicate between source and destination. Even we are communicating using one language, which is English language. Same way in our storage boxes also, if you want to communicate from ESXi host to sandbox, we require, it depends on the storage model, we need to choose the specific protocol. If it is a fiber channel SAN, and our protocol is fiber channel protocol, and if you are using a iSCSI, we can use a iSCSI protocol. For normal local system, we can use SCSI protocol, small computer system interface. And if you are using a NAS storage, protocol is NFS. And even for the normal systems, we can use a CAFS, common internet file system. Suppose if you want to use a data store in your cloud environment, the protocol name is S3. S3 is the protocol for the Amazon storage, and the S3 full form is simple storage service. So this is also protocol to access your cloud-based storage, data store or storage, any terminology we can use. And this is about the protocol information. When comes to the location storage, where we can configure the storage, either you can configure in your on-premises data center, or you can configure in a cloud. Nowadays the most common terminology is cloud. Cloud also we have a multiple terminologies. Suppose if the cloud is in a public cloud means data center is not in our on premises, it's managed by some other third party vendor, which is Amazon, Microsoft Azure, Google Cloud. So these are data centers are not in our on premises, but still we can provision the VMs on a remote Amazon site or Microsoft Azure site, or we can configure in a Google platform. So these are all consists as we can call it as a public cloud. Suppose if you want to configure the cloud on your on-premises environment, and it's completely privately we can configure, and we are providing the access to the some of the customers. That is nothing but a private cloud. So it's like a vehicles also. We have a public transport vehicle and private vehicles. Private vehicles means it's dedicated to some person. Same like in the IT environment also. If it is public means it's anyone can log into the portal and can configure the virtual machines. But in the private means it's dedicated to the certain group of people only. Okay, certain organizations only. Okay, and within the cloud terminology, we discussed two terminology, public cloud and private cloud. Similarly, if you want to combine in your organization, we are using a combination of private and public both, then we call it as a hybrid cloud. And try to understand this terminology. When your organization on premises, we are using the both private cloud and also the public cloud. That means it is considered as a hybrid cloud. And now another terminology is multi-cloud. What is multi-cloud means? Suppose your organization not limited to a one private cloud, not limited to a one public cloud. If you are using any one additional cloud, any one additional private or any one additional public cloud, if you are using, that is nothing but a multi-cloud. So suppose if you want me to explain one example for multi-cloud is, let's say my organization currently we are using a on-premises servers. I have a data center. I am using a few of the servers in my data center, but still I configured few virtuals in a private cloud environment and some virtual machines in a public cloud environment. And also I also trying to use some of the for mail servicing. I'm using MS Office 365. That is also one of the cloud platform. We are using also one, either you can use a drive like you can use Google Drive or you can use a OneDrive or any of the Dropbox. This is also one of the storage level clouds. And when not only limited to private and public, if you use any of the external third party cloud, your environment consider as a multi-cloud. Okay, so the data store can be configured in any of the cloud environment, or you can configure on a on-premises data center also. And now come to the storage. Storage means mainly we are using storage to store our data. But data, when you comes to the data, the storage will be, we have a three types of storages. First one is, we can say file storage, and we can also say block storage, and another one is object storage. And until now we discussed the concept of file storage. So what is a file storage example is NFS. NFS is a file storage. And block storage means our local hard disk and also the direct attached disk and the sandbox. It is all considered as a block storages. And come to the object storage, our vSAN is considered as a object storage. And in our previous session, we discussed the more differences between file storage, block storage, and object storage. So I'm not going to the deep now. I'm just giving the quick introduction of these three storage types. And our today's concept, vSAN, is comes under the object storage. Okay, and quickly we can verify the definitions. SDS allows a greatly increased amount of flexibility in storage options. There are multiple storage options. Okay, and the first one is block storage. Block storage, we can also call it as block level storage. Data is saved in fixed sized volumes called blocks. Fixed size volume means it's nothing but a LUNs. You can configure the LUN for 1 TB or you can configure 2 TB. Depends on our customer requirement. We can assign the LUN sizes, and each block is treated as individual storage device. Yes, we have a LUN1, LUN2, LUN3, and so on, and has a unique identifier. Even we know LUN identification, LUN addressing also we are familiar, and also it has own file system. Yes, the LUN has a file system. When we add the LUN to the ESXi host, our LUN is acts the file system as a VMFS file system only. And the file storage. File storage, we can also say file level storage. Data is saved in files and folders in hierarchical system of directories and subdirectories. Even other day we configured the NFS storage using one of our Windows 2022 server. And this example for a file storage is NFS storage, and NFS storage and the protocol also using NFS protocol, and we can connect through normal IP based switch only. And object storage, we can also say object based storage. Data is bundled together with its metadata. Metadata means information such as when it was created and the size of the folder and also the who created. All this information is considered as a metadata. And also it has a unique identifier. When we create a virtual machine in vSAN data store, it will have a virtual machine when it was created and what is the size of the VM and who created the virtual machine. All this information considered as a metadata, and it's bundled together. That means our virtual machine, wherever you create, it will create one virtual machine folder. That folder is a data. It's bundled together with all the virtual machine files. Okay, and another keyword in the SDS is policy. Policy means a set of rules about the storage requirements of virtual machine and the applications they run. These policies we can set a multiple types of policies. Even the other day in our fiber channel SAN, we observed the storage path selection policies. We have a three path selection policies in FCSAN. Can anyone tell me what is the path selection policies we have?
Round robin algorithm.
Yeah, we have three paths.
But
Correct.
most frequently used.
Exactly. We have a very good. We have a three path selection policies. One is fixed, another one is round robin, and we also have most recently used. These are the three storage policies. Similarly, in our software defined storage also, we have a concept of configuring a policies, virtual vSAN storage policies. We can configure the vSAN storage policies on directly on a either data store level, or we can configure on a virtual machine level. Okay, so try to familiarize this policy terminology. Okay, and now we are going to discuss what is the types of software defined storages we have. This is the types of software defined storage. In software defined storages are several types of SDS exist in the current market, because whatever the customer they prepared one software, they make that as a software defined storage. There are plenty of SDS softwares are available in the market, but when compared to all the third party softwares, VMware Virtual SAN is one of the most popular software defined storage. But here I'm trying to explain a three types of SDS, but it's not limited to these three. We have plenty of software defined storages, but just try to understand these three. These three are the very key concepts of SDS. Okay, and I mentioned the same point here. Several types of SDS exist. This may include, but are not limited to only these three. We also have plenty. Yeah, I just put the one internet picture. See, we have not only these three, we have multiple SDS options. Whatever option you want, you can use it. But the most popular SDS options are these three. The first one is hypervisor based. We know hypervisor means our ESXi operating system. We call it as a hypervisor operating system. Hypervisor based, a storage hypervisor that helps manage multiple pools of storage. If you group the multiple hard disks, or if you combine the multiple hard disks, we call it as a multiple pool. When you combine the multiple local hard disks, you can make it as a hypervisor based SDS. Then the example for that is VMware's vSAN technology, virtual SAN technology. And another point, hyper converged infrastructure package. Hyper converged means the word is taken from the letters hyper and converged. Converged is nothing but a combination. It's a combination of, if you combine, if you observe in the first step, it's only for the server combined with a storage. Suppose in the second option, this option packages compute, storage, network, and virtualization. See here we have a four combinations in the same hardware. These combinations we call it as a hyper converged infrastructure package. And also the another word for the hyper converged infrastructure package word is SDDC. We can also call it as SDDC, software defined data center. With the software defined data center, we have a virtual servers, we have a virtual networking, and also virtual storage. Okay, so try to familiarize this terminology. And the third one is container based. Nowadays, everywhere the containerization also getting very popular these days. And containerization and advanced containerization is Kubernetes. In our later classes, we focus on the containerization as well. And just understand the definition. Containerization based means software defined storage that specifically built for a container environments, such as Docker. Docker is one of the example for containers. Even if you prepare a software defined storage only for to store your all your Docker engines, that is nothing but a container based software defined storage. Okay, is it clear? Before we jump into the virtual SAN architecture concept. Okay, let's start the virtual SAN architecture framework. So we have a virtual SAN architecture framework, same like our previous FCSAN, iSCSI SAN, NFS. We observe the what is the architecture looks like. The same way here also we can try to understand the virtual SAN architecture. What is the main key components also involved in the virtual SAN architecture? So let's start with the bottom to top. Suppose in this diagram, if you see here, we have a virtual SAN cluster aggregated data store. Aggregated is nothing but a combination or joined together. Okay. Sometimes we can call it as vSAN aggregated data store. Sometimes we can say vSAN cluster data store, or sometimes we can call it as vSAN data store. But all the terminologies are same. Okay. So that's why I mentioned all terminology here. So this is the one common virtual SAN data store. How it's configured is, if you observe the diagram, in this diagram we have a 3 ESXi host, ESX1, ESX2 and ESX3. But here I highlighted that the minimum requirement to configure virtual SAN is we require minimally 3 ESXi hosts. That is a requirement as per the VMware official documents. And we can also, if you want to later, if you want to increase your vSAN clusters, vSAN ESXi host, maximum we can increase until the 64. That is a limitation as per the VMware configuration guide. So that's why I highlighted here. The minimum to configure virtual SAN, we require 3 ESXi hosts, and the maximum we can configure 64 ESXi hosts. Okay. And each ESXi host, we have a flexibility to use the hard disk. Either you can use all SSD disk, or you can use combination of hard disk drive and SSD, solid state drive. Any combination you can use. But primarily we need one SSD minimally, and also we need another disk can be either HDD you can use, or you can use SSD. That combination can be we can use. But how we can use this combination and all, I will explain you in the following slides. Okay, but the disks is the common. Every ESX host have a local hard disk. When we group all these local hard disks, we are preparing a one storage cluster. So that means we no need FC-SAN switches, we no need normal network switches. Using a just ESXi host existing local hard disk, we are preparing a one vSAN clustered data store. Why I mention we can cluster data store is we already know vCenter cluster concept. Cluster is nothing but a grouping of multiple ESX hosts. Similarly, when we group your multiple ESX host hard disk, it will become as vSAN clustered data store. Okay, and in your all the ESX hosts, the common product is vSphere. vSphere means ESXi and vCenter server. But for the virtual SAN, we no need any additional software. vSAN is completely integrated with vSphere itself. Okay, there is no additional software requirement. And on top of this vSphere, vSAN, we are creating the virtual machine same data store. And this virtual machine can be normal virtual machine. You can install guest OS and applications, or you can also provision the virtual machine appliances also. Appliances, one example is vCenter server. Even our vCenter server is a one of the appliance virtual machine. We no need to install the separate OS, separate application. It's already a predefined virtual machine. So like this, any type of pre-configured VM or normal virtual machine, it allows you to store all the VMs on your virtual SAN cluster data store. Okay. So now left portion, we can try to understand the description points. Virtual SAN is a software-defined storage solution providing shared storage for vSphere clusters. So it's providing a shared storage for vSphere cluster without using traditional external storage. Traditional external storage means NAS box, SAN box, we no need. Without SAN and NAS box, we are configuring using local hard disks. Okay, and vSAN is fully integrated with vSphere. Okay, it's a completely integrated concept, and it is an object-based storage system that aims to simplify virtual machine storage placement decision for vSphere administrator by leveraging storage policy-based management. This same concept same point we discussed in the first slide. Normally using the vSAN, one key benefit is we can maintain in a policy based management. Our vSphere administration can create a multiple vSphere storage policies, which policies include one policy for dedicatedly for RAID 1, one policy for RAID 5, one policy for RAID 10. But if you want to configure different storage policies, conditions apply. We have to have this many ESXi hosts, minimally 3 and maximum 64. Based on your requirement, you can have a maximum host and also configure your additional hard drives also to support RAID 5, RAID 6 and RAID 10. Okay, so that is a point here. And now the same diagram will also discuss some additional components in vSAN architecture. In the virtual SAN architecture, we have the components. These components include when virtual SAN is enabled on a cluster, a single vSAN data store is created. But how it is created is using the data store uses either hard disk drives or solid state drives of each host on the cluster. Every host have a multiple disk. These are also components of the our vSAN. And where we can enable the vSAN is we can enable vSAN feature in a cluster only. Suppose if you want to verify this option, just quickly log into our lab system. Connecting to the our 40 workstation. Okay, our vCenter server is up. Here recently I just readjusted our lab system, and one vCenter IP I changed it to 60. Let me log into the vCenter server. IP address is 60. Yeah, 60. Okay, when we connect to our vCenter server, seems there are some warnings. It's fine. I'm just clearing the warnings. But in the office environment production system, we need to resolve those warnings. Okay. When we connect to our vCenter server, we know already how to create data center, how to create the cluster, and how we can add the ESXi host. Suppose right click the ESXi host cluster, go to the edit settings. It will redirect it to the cluster configuration settings. Under cluster configuration, select new cluster. Right click here, select new cluster. While creation of new cluster itself, you can find the virtual vSphere cluster have a 3 options. You can enable the DRS, distributed resource scheduler, and you can enable HA, high availability, and one of the feature is vSAN. So that means vSAN means it's a one of the vCenter cluster feature. When you enable vSAN option, that means the cluster will acts as a vSAN cluster. Okay, and to manage this vSAN cluster, see we need to add all these hosts to the vSAN cluster. Okay, I will show you in our during the lab session. I will show you how we can add and all, but try to understand that vSAN feature is coming under the cluster feature only. Okay, and also in our test lab, I just tested all the data store configuration for vSAN. If I go to the data store, we configured the vSAN data store. Even the data store type it is showing as vSAN. Suppose if you add a local storage file system type, it shows as a VMFS, but the vSAN file system type also vSAN only. Okay, so this is how we can configure. When we enable the vSAN cluster, all the disks, whatever disk we have in the 3 ESXi host, all disk it will become as a one virtual SAN. Okay, and even the disks how we add and all I will show you today. The same point mentioned here. When virtual SAN is enabled on a cluster, just now we observed where we can enable the vSAN feature. It's on a cluster only. A single vSAN data store is created. Even we observed in our lab, one single vSAN data store is already created state. But how the data store is created is the data store uses the storage components, hard disk drives, and also we can use STDs. But this is a flexibility we have based on your available disks you can configure. Okay, and a vSAN cluster requires, if you want to configure a vSAN cluster, this is the main key configuration requires minimum of 3 hosts to be part of the vSphere cluster and enable for virtual SAN. So minimally we have a 3 ESXi hosts. So that is the reason in our lab system we added a 3 ESXi hosts, 61, 62, and 63. Using this 3 ESXi hosts, we configured the virtual SAN. Okay, and a vSAN network. vSAN network means create a VM kernel port group and enable vSAN service. We know already how to create a VM kernel port group. In our virtual switch level, we have a concept of creating two types of network connection types. One is VM kernel port group, another one is VM network port group. But to configure virtual SAN, we required a VM kernel port group, that VM kernel port group to enable with vSAN service. Okay, we can quickly observe where we can have this VM kernel with vSAN service option. Just log into our system, select the ESXi host, go to the configuration tab. Under networking, go to the VM kernel adapters. When you select the VM kernel adapters, if you see here, we have three network adapters: VMK0, VMK1, and VMK2. VM kernel adapter, first one is connected to management port group, another one configured with vSAN, another one configured with vMotion. But how we can configure vSAN is while adding your network port group, select the VM kernel network adapter. In the description itself, the VMware clearly mentioned that VM kernel's TCP stack handles the traffic for ESXi services such as vMotion, iSCSI, NFS, FCoE, fault tolerance, and also it's supported for virtual SAN. So our today concept is vSAN. To configure virtual SAN, we must and should have a VM network adapter connection. When we enable vSAN network adapter connection only, it allows you to configure a vSAN cluster. So suppose if I click on next, you can choose either a new network or you can choose a existing virtual switch. Let's say I'm selecting the existing virtual switch. While creation of VM kernel port group, under the available services, we have a option for vSAN. Okay, so this point only I'm explaining in our slide. A vSAN network, that is create a VM kernel group and enable vSAN service. So vSAN is considered under the available service only. Okay. And the last point, local disks on the each host. So each host in the diagram, we have a local disks. Okay, each host have local disk. Local disk on each host that are pooled. Pooled means it's a combination or you can join together to create a virtual shared vSAN data store. So by combining all the disk only, we can create a vSAN data store. Now we can observe within these disks, we have a, even in our diagram, we have few SSD disk, few HDD disk, even VMware also, they divided this when we are using a different combination of hard disk, they prepared a different architecture types. We have a two types of architectures. We can discuss the vSAN based on the disk. We can discuss what is the vSAN architectural differences. So this diagram will explain us vSAN architecture have a two types of architectures. One is a hybrid architecture, another one is a all flash architecture, and try to understand what is difference between all flash architecture and hybrid architecture. Suppose when you see the diagram here, the virtual SAN can be configured in a all flash architecture or hybrid architecture. When it comes to the all flash architecture, in the diagram you can see we have a SSD, solid state drive, and we can also have PCIe. PCIe means peripheral component interconnect extension. This is also acts as a one SSD disk, and non-volatile memory. This also acts as a SSD disk. So we have either any three types of disk we have, and also we have a all SSD. If you see in this all flash diagram, all are a SSD disk only. There is no HDD disk. So that means it's considered as a all flash vSAN architecture. When it comes to the hybrid architecture, within the hybrid architecture, in the first row, whatever we have, even in the hybrid also we have same SSD, PCIe, and NVMe. But only difference is instead of SSD disk, we have a SAS disk. SAS means It's a serial attached SCSI, or we can use a NL-SAS disk, or you can use a SATA hard disk. SATA also serial advanced technology attachment. These are all the old model of hard disk drives. But why I need to use this hard disk is normally SSD hard disks are a bit expensive SSD disk when compared with a normal SAS and SATA hard disk. Suppose your customer do not have a much budget, all your ESXi hosts, he want to maintain one SSD and the remaining disks are he want to maintain a less cost. That means low configuration of disk. Then we can go for a hybrid architecture. Suppose your customer is okay to purchase all the high configured costly storage disk, better you can go for a all flash architecture. Depends on the disk type, the architecture is changing. Okay, and let's try to explain the some additional options of this architecture. And always the first disk is considered as a cache tier or caching tier, and the second disk is considered as a data persistence. And for our easy understanding, in our laptop also we have a RAM and storage local hard disk. RAM is considered as a memory. This memory is always a primary storage. And also our local hard disk is considered as a secondary storage, which is permanent storage. Similarly, in our virtual SAN also, always the first hard disk is a caching. Caching means it acts like a memory only. It's a temporary storage. But our permanent storage, data persistent, permanent storage is always in a capacity tier. We call it as a capacity tier. This capacity tier consists of multiple SSD disk in all flash architecture. When comes to the hybrid architecture, instead of SSD hard disk, we are using a different model of low configuration hard drives, which is either we can say HDD or we can say SATA, SCSI, and SAS. This is the old model of hard disk. When you're using a old model of hard disk in your capacity tier, your architecture name consider as a hybrid architecture. Okay, is this point clear? It's the same like our local system. The first one, cache tier, is nothing but it acts like a memory, and the second disk is like a secondary storage, which is our permanent storage, data persistent purpose. Okay. The last point I mention is vSAN can be configured as all flash storage architecture and hybrid architecture. It's subjected to be customer requirement only. But as a vSphere administrator, we should understand what is the hybrid architecture means. Hybrid architecture means not only SSD, we are using a combination of low configuration of hard drives. When comes to all flash, when they say all flash means all are the SSD hard drives. Okay. Now, within this hard disk, there is another concept called disk groups. How we can group these disks and all, we can discuss now. So vSAN architecture disk groups. So disk groups also, vSAN uses the concept of disk group to pool together a cache devices and capacity devices as a single management constructs. And also the disk groups are combined to create a single vSAN data store. Suppose in this diagram, if you observe that we have as we know, we require one physical host. On top of the physical host, we install the vSphere, and vSAN is not a separate software. It's already integrated with vSphere product. So that's why we put the icon like this. And in this diagram, if you observe, all is the all flash vSAN. All flash vSAN means there will be no HDD drive, all are the SSD drives only. Okay, when we have SSD drives, we divide it into two types. One is cache tier, it's the same like our laptop memory, and another one is permanent disk, which is called as technical term in the vSAN concept is capacity tier. Okay, and the cache tier, we always required minimum one SSD disk, and the capacity tier you can configure multiple hard disk. And if you want to create one disk group is nothing but a one data store or one LUN. Normally in FCSAN, we use the LUN, and when adding to the ESX host, it's configured as a VMFS data store. Same way, in our virtual SAN also, if you want to create one data store, this disk group you can make it as a one data store. Suppose in later in future, if you want to configure multiple data stores, again you can dedicate one SSD for cache drive and the multiple SSDs for capacity tier, and group these two and make it as a one data store. And why they are giving a cache tier means this is and all to enhance our data storage level read write performance. Okay, and the same point we mentioned here. A disk group requires one flash device for caching. For cache level, we require a 1 SSD and 1 to 7 capacity device for storage. See, capacity device not only limited to 1, minimum is 1. We can add maximum 7 based on our VMware configuration guide. So we need a minimum is 1 capacity also. We can create one disk group, or else you can create 2, 3 until we can create 7 capacity devices to make the storage disk group. Okay, and the maximum of 5 disk group per host. That's why in this diagram, how many disk group we have? One disk group, second, third, fourth, 5. Each ESXi host, it's supported to create the disk groups maximum 5 disk group only. This is also as per our VMware configuration guide. Okay, so once this point is clear, we can move on to the disk groups. Also, there is a two types of design considerations. I will explain the two design considerations as well. These are all required before we configure the vSAN in our lab. So anyone have any questions on this point? Once we understand, it's easy to understand the disk group designs point also. So this last point is important. Every disk group require one flash device. That means one SSD drive for caching, and minimum is one capacity drive. Maximum we can create 7 SSD drives for capacity tier. Okay, one SSD means it's like a even in our laptop we can have a one memory RAM card, one memory, and we can hard disk. We can add multiple hard disks. Same concept here also. And within one ESXi host, how many disk groups we can create? We can create the disk groups, 5 disk groups maximum. Okay, so now we're going to observe the disk group consideration. Suppose I have one SSD and I have a instead of 3 capacity tier, I have a 10 capacity tier. How we can break it into multiple disk group? That is considered as a disk group designs. We'll observe the disk group designs now. So vSAN architecture disk group designs. In this diagram, I'm trying to explain two designs, design 1 and design 2. Let's understand the design 1 first. There are few reasons to consider using a multiple disk groups. Okay, here if you see in the first diagram, we have the 6 capacity devices, and always remember for buffer and cache, we required only one SSD. Even in the second one, we have a 2 disk group, and each disk group one SSD is common, and the capacity tier instead of 6 into the one disk group, they break it into the multiple disk groups. And see the same point I explained here in our description. In the design one disk group with one cache device and 6 capacity devices. And when observe the this design 2, we have a two groups. Two groups means disk group 1 and disk group 2. Two groups with one cache device. We have one cache device and 3 capacity devices. Okay, we have a 3 capacity device. And also I mentioned one point is there are few reasons to consider using a multiple disk groups. Let me try to elaborate why we need a disk groups, multiple disk groups. For example, when we consider a disk 1, a design 1, in this design 1, we have only one data store. Disk group means it's nothing but a vSAN data store. We have a one data store, our virtual machine 1 is running here. Suppose in future, all of the sudden, my virtual machine is down or my virtual machine is corrupted. Somehow my virtual machine having some issue. If I want to restore my virtual machine, restore means if we have a virtual machine backup, using the backup, we can restore our virtual machine to data store. But when I trying to restore to the same data store, this VM name is already exist. If you want to restore some scenarios, it won't restore here. It will give you error message says there is already existing virtual machine is in place. So what is the solution during that scenario? The only solution is we can rename the existing virtual machine to, you can rename like VM underscore old, and you can restore the new restore virtual machine. That is a solution in the design 1. Suppose if we have a design 2 scenario, we have a 2 data stores, disk group 1, disk group 2. My virtual machine is running on a disk group 1. Somehow all of the sudden my virtual machine 1 is down. or some having some guest OS level issue. So most of the scenarios we try to resolve the issues. In case of if you are unable to resolve the issue, the final solution will be we have to restore our virtual machine from the existing backup. Let's say when you are restoring, but in our second design we have a two data store, we no need to disturb the first data store, you can restore it on a second data store. When restoring to the second data store, there will be no error messages because there is no virtual machine registered on the second data store. This is the one example for why we need to prepare a multiple disk groups. Even if you want to ask for another example, let me try to explain another example. Let's say, for example, my virtual machine is running with any of the application. Let's say my application is SQL Server 2014. SQL is a Microsoft database server name, application name. Microsoft SQL 2014 is running on my virtual machine. Suppose in future, I'm planning to upgrade my Microsoft SQL Server 2014 to, I want to upgrade it to the latest version, which is whatever the available latest version, let's say 2019 or 2021, whatever the latest SQL version is available. If you want to upgrade without disturbing our production environment, what is the option is we no need to disturb this virtual machine. We want to create a clone and you can do the your upgrade test. But if you want to do the upgrade test on the existing data store, sometime when we create a clone, even if we need to change the virtual machine name and all, without changing the name, if you want to do the same test, it may says that the virtual machine is already exist. Obviously, when we are using in a design one scenario, we have to rename the copy to the different name. Suppose when you are using a two different data stores, you can create one virtual machine running here and another virtual machine. You can create a clone onto the second data store and rename the virtual machine and do your upgradation test without disturbing on the existing data store. So this is also another scenario. So like this, there are multiple reasons why we require to configure one ESX host, why we need to go for a multiple data stores. Okay, but this multiple data stores for each host, as per VMware design guidelines, we need to configure one kind. So I give an example in which scenario we'll go for a second data store. Okay, hope you understand this point. Now we can going to observe as per our vSAN architecture. Until now, we observe here how many disks we required, how many ESXi hosts are required. Now we also discussed about the components in the vSAN. Now we are going to discuss the virtual SAN. Within the virtual SAN, how many hardware requirements? What is the main key hardware requirements are we need to meet to install the vSAN data store or to create a virtual SAN data store? Let's observe the hardware requirements now. See the hardware requirements. We have a hardware requirements here. Uh, Minimally, we required one server, and that server should be in the vSAN compatibility guide. We know in our Google, if you type vSAN compatibility guide or VMware compatibility guide, you'll get a one PDF, or you can directly check in the website. Whatever the server you're going to install the ESX server and going to configure vSAN, this model must be compatible with our virtual SAN concept. There is a chances few model of hardware is not supported with a virtual SAN. So before configure, make sure that our hardware must compatible with virtual SAN configuration. And this compatibility guide, we can also call it as HCL. HCL, it's not a company name. Here the HCL means it's a hardware compatibility list. You can verify in the hardware compatibility list, our server have a compatible, it's a compatible or not. That is our primary first verification. And the second verification, as we discuss in our disk group concept, we need one SSD mainly for caching, at least one SSD. If you have another SSD, you can create a second group, second disk group. Okay, and we also need either normal HDD disk or STD. That's why I mentioned as one SSD or one HDD, at least one SSD for capacity tier or HDD for hybrid mode. Normally, if you are using HDD means we consider as a hybrid mode. Okay, so we are familiar for this technology now. And come to the network, because server means we covered with a CPU memory. Already it's in the compatible list. After CPU memory, we verified the disk. Disk also we must one SSD for caching, one HDD or one SSD for capacity tier, and then we need to verify the network. And network means either you can use onboard motherboard itself, it have a RJ45 port like our laptop. Also some laptops comes with a LAN card port, or else if your server do not have LAN card, we need to insert a external LAN card. This is a LAN card looks like this. And the LAN card also, if you want to configure virtual SAN, minimum speed is 1 Gbps network speed, and VMware recommended speed is 10 Gbps. Even if your network is very critical, you can configure more than 10 Gbps network also for better performance. Okay, and also IP address, vSAN is support for a both IP version 4 and IP version 6. Any IP version series we can use. We already know IP version 4 is 32-bit addressing, and IP version 6 is 128-bit addressing. Okay, so any format we can use the network vSAN also supported for any type of IP address. And the last key point is we required a RAID controller. So RAID controller means even in our local hard disk, if we have two hard disks, the recommended RAID is RAID 1. If we have more than two hard disks, we'll configure RAID 5, RAID 6 or RAID 10. Why we need to configure RAID is mainly for redundancy purpose. Even the RAID full form itself, it clearly says redundant array of independent disks. So if you configure the RAID, in case of any disk is failed, there will be no impact to your production virtual machines. So we required minimally network card as well as one RAID controller card for our physical box. Okay, so the same point I mentioned here, RAID controller must work in pass through or HBA mode. Generally, this RAID controller cards are using a HBA mode. HBA means we already know host bus adapter mode, and our network card have a unique MAC address, but in the RAID controller card have a unique WWN number, worldwide number. Okay. And another two important points here, not every host in virtual SAN cluster need local storage. Suppose my vCenter server vSAN condition is we require a minimally more 3 ESXi host. See, if you see here, our basic point we mention as minimum requirement for virtual SAN is 3 ESXi host. Suppose I want fourth ESXi host, my fourth ESXi host do not have a hard drives, but we already have existing three hosts configured with vSAN Datastore. During that scenario, if your fourth ESXi host does not have your hard disk also, VMware says that not every host in virtual SAN cluster needs a local storage. If you do not have one host, there is no hard drives in the hardware, still it's supported to configure under the virtual SAN. But the condition is first three hosts must be running with a hard drives. And the next point, host with no local storage can still use distributed storage. Even if there is no host data, the hard disk on that host, still it can able to access the virtual SAN data store. Okay. Now we are going to observe the virtual SAN data store objects now. I accidentally press end button. See, we discussed until here components, we discussed hybrid versus all flash, we discussed disco groups, we discussed hardware requirements, just now we discussed. Now we are going to discuss the data store objects. Data store objects is nothing but a virtual machine folder. Every virtual machine folder consists of all virtual machine files. So the same point I highlighted here. So virtual vSAN data store objects is nothing but a virtual SAN cluster store and manages data as flexible data container called objects. So object means it have a virtual machine folder, snapshot file, VMDK file, virtual machine swap file. All these are stored on a vSAN data store, and these files and all we consider as a objects. So that's why vSAN also consider as a object based storage. And when we provision a virtual machine on vSAN data store, a set of objects are created. Those objects are we already familiar. Every virtual machine name have one virtual machine home namespace. Let's say my VM name is VM1. We'll have a VM1 folder. Inside the folder, what we can get, store the virtual machine metadata. Metadata means configuration file, which includes the traditional virtual machine file extension is VMX. VMX means virtual machine configuration file, and NVRAM means it's a BIOS file, log file, and also there will be some external log files as well. And VMDK. VMDK means it's a virtual machine disk file, and file extension is .vmdk. .vmdk means it's a virtual machine disk descriptor file, and the data is actual data is stored under the hyphen flat .vmdk. This data, this disk only consists the actual virtual machine data file. And another file is snapshot delta. This snapshot delta, when it is created, is when created a virtual machine snapshot, then only this file will created, and extension is 001.vmdk. Here 001 means this number will keep vary. This number only we call it as a delta value. Okay. And virtual machine swap extension is .vswp. This swap file will create when virtual machine is powered on only this file will be created. And virtual machine memory, this memory will create when virtual machine is suspended state, or during the snapshot creation you can enable the memory state option. It will create a .vmem file. Okay, so in this diagram it's the same. We have three ESXi hosts, it's running with multiple disks. All these disks combined and we make it as a vSAN data store. Okay, so now we can observe the vSAN virtual machine storage policies. This is the storage policies concept. So within our virtual machine storage policies, vSAN storage is a object based and policy driven. Policy driven means you can set any virtual machine storage policies. Uh, Most of the time, most preferable storage policies are three: capacity, availability, performance. Let me give you an example for capacity. Capacity means, suppose if you want to set a one capacity policy, like let's say my virtual machines, I want to configure as a different policies. That capacity is large, medium, small. Even during our virtual center installation time, we observed that virtual machine we can configure in a multiple sizes, like a t-shirt sizes: tiny, small size, and also we have medium size, large, X large. Only difference is large, X large means the configuration of CPU, memory, disk size are increasing. Even the virtual machine capacity also same. Even if you set the policy for capacity policy is large, whenever you create the virtual machine with the large storage policy, by default virtual machine disk is configured with 1 TB. That size is, it's up to our internal configuration. Suppose I set that large configuration means by default VM should created with 1 TB size. And I also set another policy for medium. My medium size means 500 GB. Whenever you provision a virtual machine using the capacity of medium policy, the VM will configure with 500 GB. Suppose the low means it will configure with a 100 GB. So these capacities we can set on a storage policy level. Let me quickly show you where we can see the policy option. Suppose if I just cancel here, if I want to create a virtual machine, right click the ESXi host, select new virtual machine, click on new virtual machine. You can set any VM name, let's say VM1, click on next. While creation of virtual machine, we can see the options here: virtual machine storage policy. And the default it's showing as default storage default. If you scroll down here, you will find a multiple default policies. These policies and all we haven't configured yet. It's a default coming in a vCenter level. Management storage policy: large, regular, single node, stretched. These and all comes under configured as a storage policies. This policy point, and also there is a vSAN default storage policy. Remember that default vCenter storage policy means it's a configured default with RAID 1 configuration. RAID 1 means all your ESXi host disks is configured with RAID 1 mirroring concept. In case of any hard disk is fail or it's become faulty also, there will be no impact to your production because there will be a mirrored disk is available when you configured with vSAN default storage policy. Okay, these are all the policies. Okay, so the same point I mentioned here. Not only in the capacity, we can also configure the availability level. Availability example is vSAN default policy. Availability means in case of hard disk is fail also, still our data is available on a another hard disk. And even you can configure in a performance layer also, you can configure the policy. Okay, let's understand the points here. Even in the diagram, if you see, we have one ESX box. vSphere is integrated with vSAN. On top, we created a vSAN data store. vSAN data store running with virtual machine. This virtual machine, we can add a policies. Suppose you already configured a virtual machine, the existing virtual machine, if you want to add a policy also, you can just right click the virtual machine, go to the edit settings, we can find the policies. Let's minimize. Understand these points also. Virtual machine storage policies are a same like set of rules that we can configure for virtual machine. We should create storage policies before deploying the virtual machines that require these storage policies. We can apply and update storage policies after deployment. Either you can create before itself, you can create, and even once the VM is created, later also you can assign these policies. And the storage policies have the following characteristics. Characteristics means it have some features. These all the storage policy features based on the storage capabilities. Capability means just now we discussed. We can configure like a different sizing and define for virtual machine or disk at the time of deployment. You can apply the policy either on VM level or you can apply on a disk level also, and can be applied later. That means once the VM is provisioned, later or post deployment also you can assign. We have that facility, and can be changed at any time. Suppose you want to modify the virtual machine policy, we can modify anytime, and cannot be deleted if they are in use. So it's a default functionality. When you are already assigned the policy to one virtual machine, if you're trying to delete, it won't delete because it says the message is it's already in use. Okay, this is about the virtual machine storage policies. So now we are going to discuss the vSAN data store use cases. So we have plenty of use cases. So I'll just give you the brief overview of all the vSAN use cases. But in our end of the vSphere concepts, if you are interested, I will cover the remaining advanced vSAN concepts. But here I'm just giving you the introduction points for vSAN main real-time scenario use cases. So the first key use cases are, just now we discussed storage policy we can apply for virtual machine level. So with multiple policies per data store, each VM can have different storage. So this is option available only in the vSAN. This option is not available in our FCSAN and NFCSAN. And another point, vSphere and vCenter integration. vSAN capability is built in and requires no appliance. Just now we are going to configure vSAN. How we can configure? Just log into vCenter, right click the cluster, while creation of cluster enable vSAN. So that's it. There is no appliance for vSAN configuration. It's a one of the vCenter cluster feature only. We can create vSAN cluster like vSphere HA, vSphere DRS. Even during cluster creation, we can see these two features also. Scale out storage. Scale out is nothing but adding the additional capacity. Suppose your virtual vCenter level, during the initial setup, I added a 3 ESXi host. Later, if you want to add additional ESXi host, our one of the use cases, you can add the ESX host until 64 ESX host can be in a cluster. And scale out by populating a new nodes in the cluster. We have an option to add a new additional nodes. We can expand our cluster capacity. And built-in resiliency. So resiliency means how much its availability. So the default vSAN storage policy establish RAID 1 redundancy for all virtual machines. RAID 1 means it's a mirroring concept. Whatever the disks you configure, all disks will be mirrored to the second hard disk. Okay, and let's observe some more additional vSAN use cases. So these are the additional vSAN data store use cases. vSAN supports for a broad variety of use cases. I'm trying to explain a main 8 use cases here. Let's start from left to right. Let's say the first use case is business critical applications. Even if you have any business critical applications in your infrastructure, still you can create the business critical applications directly on a vSAN data store. We have a facility. And if you have any databases like Microsoft SQL or Oracle database servers also you can create on a vCenter server data store. And we can use vSAN data store for disaster recovery purpose as well. Disaster recovery means we must have a two different sites. One is primary site, another one is secondary site. When the primary site is any disaster happen, you can restore it to the disaster recovery site. That means second available site. And we can configure management clusters also on a vSAN, and it will support for robo. Robo full form is remote office branch office. Suppose in my organization I have some remote office and branch offices. Even in your remote branch office also, it allows you to configure a vSAN data stores. And container is the latest application platform. So earlier all our applications are in a monolithic application structure. Let's say before VMware, all our applications running directly on a one single server. That is nothing but a monolithic architecture. When comes to the virtualization, most of the applications are migrated to three-tier architecture. Three-tier architecture means any application we can configure in a web three tier. The three tier involves web tier, app tier, and DB tier. For example, if you take any website, like if you want to book any of the taxi and all, we are using a Uber app. Uber is one of the popular app to book a taxi. That application is running on a app server, and to access the Uber website, it will run on a web server, and all our transaction data, everything is stored on a database. That means to run one Uber app, backend it require a three servers. That three servers are web server, application server. To maintain all your data for Uber data is you require a database server. That is nothing but a three-tier architecture. But when comes to the latest platform, latest next generation of applications are all become as a microservices. That microservices we can configure like a containerization all along. Okay. In our later classes, I explain more onto the containerization. This is also one of the interesting concept I will cover in the later sessions. And even in the similar kind of application, if you want to configure on a cloud native level, not only the vSAN in a on premises, you can configure on a private cloud, you can configure on a public cloud. For private cloud, we can use like a software called VMware Cloud Foundation, VCF. Using VCF also we can configure virtual SAN. And we can also configure virtual SAN for virtual desktop. Nowadays virtualization not only in the server virtualization, desktop application virtualization, storage virtualization, network every hardware component become virtualized. So this vSAN is also supports for a desktop virtualization product, which is virtual desktops. You can configure virtual desktops also on the vSAN data store. Okay, this is the high level overview of vSAN data stores main use cases in real time scenarios. Okay, and the last point, a platform capable of running traditional and next generation applications. Next generation application means containerization. Okay, so this is about the vSAN theoretical concept. Now we'll go for a lab. So in our lab, we are going to observe the vSAN cluster setup. So how we can create the vSAN cluster, and while creating the vSAN cluster, we have a two options. Just now we observed while creation of cluster itself, we can enable vSAN. But vSAN, we can configure in two methods. First method is we can configure in quick start method, and the second method is manual method. Okay, I will show you two methods. We have two two remote lab systems. One lab system, I will show you quick start method, and another system, I will show you manual method. Okay, and validate the vSAN data store configuration. We can also validate the whatever the data stores are available, all the data store configuration we can validate, and vSAN cluster health status. Once the data store everything is created, we'll verify vSAN cluster how is the health status, and verify the virtual machine on vSAN data store. We can create one virtual machine on vSAN data store and observe the vSAN virtual machine objects. Objects is nothing but a virtual machine files, VMX, VMDK, NVRAM, and also the virtual machine log file and snapshot file. So this is the lab we are going to observe now. Uh, can we continue the lab, or shall we take short break?
Continue.
Are you comfortable to
Yes,
start
sir,
the?
continue.
Okay, okay. We can create the lab now. Let me log into the our two workstations. First one is 40, and I also connected to the another workstation. It's a 100. So here our vCenter IP address is 79. Okay, so one vCenter I will show you the quick start method. Another vCenter I will show you the manual method. Okay, let's minimize this and we can open a browser and connect to our vCenter server. vCenter IP is 79. Launch the vSphere client. So once we log into the vCenter server, assign our admin credentials. Okay, it seems to be one ESX host is showing as inaccessible. Okay, let me up. Let's try to reconnect. Click on next. Accept the security certificate. Next, finish. Okay. So reconnecting host is in progress. Okay, as we discussed in our previous session, suppose if I select our cluster, go to the data store. We have the data store is one data store, NFS3 is available. Suppose in our ESXi host level, first one no data store, second one NFS, third one also have NFS data store. There is some warning message. It says virtual flash resource status. Okay, there will be no hard disk and even no data stores had been configured. We'll add and configure now. Okay, so as per our discussion, to configure vSAN cluster, before we have to prepare the vSphere cluster first. Okay, before set up the vSAN. Preparation is nothing but a in our first slide we discussed the cluster requirement. See, what is our requirement to configure is minimum of 3 ESXi host. So if you log in and see in our vCenter, we have 3 ESXi host, ESX1, 2, and 3. We have already 3 ESX host. And the second point, we require a vSAN network. And vSAN network also, how we can configure, create VM kernel port group and enable vSAN service. So let's observe that we have vSAN service or not. How we can verify VM kernel port group is select the ESXi host configuration tab and go to the VM kernel, and we can see only VM kernel is available for a management service only. There is no vSAN service. So we can add a service for vSAN service. So add networking. Before adding the service, let's open our inventory sheet, and any IP is free IP to configure iSCSI IP address. Let's say ESX1 and 2, 3, we already have 3 available IPs and we'll use the IP for 84, 85, 86. Last digit is 84. Okay, the same IP I'm going to use for our vSAN configuration. I just mentioned as a vSAN VM kernel IP, VMK IP. We reserved these 3 IPs, 84, 85, 86. Let's configure the same on our system. VM kernel adapter, next, and we can either create a new switch or you can use a existing virtual switch. Click on next, and any common name we can put. Let's say vSAN, vSAN, VM kernel for vSAN. This name I'm using. And VLAN, at present we do not have any VLANs. You can use the default option, but under available services, we recommend to choose the service as a vSAN service. Okay, now click on next. When we click on next, we can configure IP address IPv4 automatically or manual. So we recommend to choose manual IP configuration. It's a default showing the some IPs. Just change the IP to 84. And the subnet mask, we can use the subnet mask and use the default settings. Click on next. So this is our summary information. We selected the port group name for VM kernel for vSAN. It's going to configure on vSwitch level, and all the services is disabled except to vSAN. vSAN service is enabled state. Okay, and MTU IP configuration also we did, and MTU we haven't modified. We are using a default 1500. But in the production scenario, if you want to configure MTU in the vSAN network level for better performance, VMware recommend to change the vSAN MTU to 9000. 9000 will be the recommended setting. But in our test lab, we can go with a default option. But in the production scenario, you can configure the maximum MTU. Okay, so now click on finish. When we click on finish, the first ESX host ready with the vSAN VM kernel network. Similarly, we can verify the second NIC. We have one NIC for management, even another NIC also for management. And here we use the 84, uh, and we can add a one more VM kernel here. Add networking. We can choose the same switch. Click on next, and the name we can choose VM kernel for vSAN. Same name I'm just maintaining. Just enable vSAN. Click on next and assign the IP address here. So IP address will be 85 and assign the subnet mask. It's auto filling. Click on next and click on finish. So second host also we are created the VM kernel for vSAN. Now come to the ESX3, and here also there is no VM kernel for vSAN. We'll quickly configure the vSAN VM kernel and assign the name. Always maintain the same name for all hosts. I'm using the same name, VM kernel for vSAN. Enable the vSAN, click on next, and IPv4 and IP address is 86 and assign the subnet mask. Click on next, finish. So VM kernel 3, it's assigned for vSAN. So as per our document, we already finished the first step and second step. We have the minimum 3 hosts we have the vSAN network, and we require a local hard disk. Let's observe how many disks we have in our ESXi host. But how many disks are required? Minimally one SSD and one HDD, but in our lab system all are a SSD only. So we can add one SSD for cache tier and one SSD for capacity tier. Instead of capacity tier one hard drive, we can add either 2 or 3 hard drives. Okay, so let's log into server. If you see the ESXi host, our ESXi host is actually a virtual machine only. Right click the ESX, go to the edit settings. We can see only one hard disk with 20 GB. So now what I'm thinking is one additional capacity tier, cache tier hard disk I'm adding first. Cache tier hard drive will add it as a 20 GB hard drive or 30 GB. Let's say make it as a 30. Okay. So single hard drive, click on next. Click on finish. So one SSD is SCSI disk is added, 30 GB. Now I need to add a capacity tier hard drive. So for capacity tier, minimum is one, maximum how many capacity tier hard disk we can add? We can add maximum 7 hard drives. Okay. So I'm adding one hard disk with 50 GB. One cache tier. This is for capacity tier. Now I'm adding one more capacity tier hard drive. Let's say hard disk next, and single file. I'm using the same size 50. So that means both 50 hard drives I'm going to use for a capacity tier and 30 GB going to use for a cache tier. Now click on OK. And same way, when we add the hard drives, ESXi host will not update the changes in the OS level. So recommendation is restart. Just right click here and restart guest. But remember, in the production environment, place the host into maintenance mode and restart. But in our test lab, I'm just restarting directly. And same way, select the ESX2 and we can add the 3 hard drives. Add hard disk, and first hard disk will choose the 30 GB. And the second we can add a 50 GB. Click on next, finish. And similarly another 50 GB. So totally we are adding 3 hard drives for each ESXi host. Click on finish. So 250s and 130, 3 hard drives are added. Click on OK. Just to apply the changes, right click the host, power, restart guest. And similarly to ESXi3, edit settings. We have only one hard drive. This 20 GB dedicated for a operating system only. And we are adding a additional hard disk for vSAN configuration. And the size we can see is 30 GB. Finish. And now adding a additional 2 hard drives. 50 GB and one more 50. 50 GB. Click on next, finish. See it 130 and 250s. So 3 hard disks are added. Now right click the ESXi host and restart guest. So this will restart. In the meantime, observe the ESX1 status. So it's already restarted and ESXi2 still restarting and ESX3 is also restarting. Okay, we'll just wait for a while so that it will create. It will boot up first. Once it is boot up, we can enable the cluster. We can enable vSAN feature in the cluster level. So as per our cluster, vSAN cluster, we already meet the 3 requirements. 3 hosts we have, we configured VM kernel and we added a local disks. The local disk we added a 3 hard drives. Okay, per each host I added 3 disks. And also as we discussed, the first hard disk always consider as a cache tier and the additional 2 disks consider as a capacity tier. And also in our capacity tier, all flash, all our SSD means its speed is 100K IOPS per host. And this is always recommended for production scenario. If your customer do not have much budget for SSD, you will go for a hybrid mode. Obviously hybrid mode, the performance will be less, 40K IOPS only per host. Okay. Let's connect to our vCenter and see the host status, all are up or not. ESX3 still booting, ESX2 up. Once the ESX3 is up, yeah, it's already up. Now we'll start the cluster configuration. Even as per the lab description notes, the first point to configure a vSAN cluster is we can configure in a using quick start method. The first point, prepare for vSAN cluster setup. We already prepared. We ready with the host, VM kernel and disks. So that is the called first point, preparation. Now we are going with a creating a cluster and enabling a vSAN, and then we are choosing the method for quick start method. Okay, so log in here. How we can choose the quick start method is select the cluster, right click here, and you can choose the settings tab. When we choose the settings tab, it will redirect you to the configuration. Under configuration, we have a DRS option. See our DRS also turn off state and availability HE also turn off state. Later sessions, I will explain detail about vSphere HE and DRS, but today's session is vSAN. So under configuration, you can see the option for quick start. When I select the quick start, see, you will find the option for cluster quick start method. This cluster quick start method, it says that no selected services. Normally the quick start method will do it in a 3 options. Option 1, cluster basics. Option 2, adding the host. And option 3 is the third step is configure cluster. So within the 3 steps, it will do automatically. Okay, so will the first step as per the cluster basics, we need to enable the service. So click on edit and enable the service. So click on edit and enable the service on our production cluster. So the service we need to enable is vSAN. So enable the service, click on OK. Just refresh here. It's already refreshing the page. So quick start method, some of the options it will do automatically. See, if you see in the recent task, it's already started. Host also we already meet the requirement. If you see the wizard here, let's minimize the recent task and let's understand one by one. The first option, cluster basics vSAN is enabled state. There is a green tick. This step is completed. Let's come to the second step. There is a exclamation mark error. Red color means error message. Let's understand all points. All are showing as green, but one point clearly says that all required hosts are in a maintenance mode. So to configure vSAN successfully, this is also one of the key point. We need to place the host in a maintenance mode. So if you want to place the host in the maintenance mode, what is the option? Just right click here and place the host into maintenance mode. But make sure that in the real-time scenario, when you are doing the vSAN cluster, when we are placing the host into maintenance mode, make sure all the virtual machines, no production VMs are running on that host. Okay, click on OK. And similarly to second host also, place the host into maintenance mode, click on OK. And the third host also, click on OK. And go to the recent task, you can see the activity status. See 3 hosts placing is in progress. Now is if you see here, the vSAN resource is already starting. Again, go to the production cluster configuration tab. Under quick start, you can observe the step 2. What is the steps 2 status now? See, we'll discuss one by one. Step 2 status, it says that add host is not configured host 3. Already 3 hosts are added. Only the configured host count is 3 hosts. If you want to add additional host, there is an option for add host. And revalidate also, just now we place the host into maintenance mode, the error become a green color now. So even in case if you have any error messages also, you can fix the error message and click on revalidate. That is the importance of revalidate option. And under the add host section, all the options are green, and we can quickly run through each option. The first option is vSAN HCL DB up to date. HCL means hardware compatibility list, database up to date. It's green. This is also green. Auto upgrade update also green. And the SCSI controller is VMware certified. There is a one exclamation mark, warning only. It's not a error message. So warning, if you click here, it will shows the SCSI controller is VMware certified information. But in the real time scenario, instead of using a physical virtual SCSI controller, we need to use a RAID controller. Today we discussed during the hardware requirement. We required a RAID controller card or storage controller card. That card we have to use, but this is our test lab. That's why it is showing the warning message. We can safely ignore this message. And the non-volatile memory identified and controller identified, drivers identified, firmware identified. All our 3 ESXi host drivers are okay. And latest version 7 only. So that is the reason. Second step is without doing manual, it's
Sir, your
everything
voice
is
is breaking.
verified automatically. Now come to the third step. Third, am I audible? Hello, is it fine now?
Yes. So your voice is breaking.
Oh, still. Okay, let me adjust my headset. How is it now?
Yes, sir. Fine.
Okay,
Okay.
okay, thank you. Uh, so we are configuring the using quick start method. So first step is finished, second step also completed, and now come to the third step. Third step is configure cluster. Under configure cluster section, let's understand the description. Configure network settings for vSAN traffic. We already configured a network setting, which is VM kernel port group, and review and customize the cluster services and set up a vSAN data store. So we already have a network ready. So we are good to configure the vSAN cluster. So just in the below, you can find the option configure. So when you click on configure, the first option it is showing as distributed switches. But until now, we configured only the virtual switches. DV switch is the one of the advanced concept in vCenter level. This concept I will cover in the following classes. So for today's session, I'm choosing the option configure networking. DV switch we can configure later because we already set the VM kernel port group for vSAN in vSwitch level. So that is the reason we can choose this option, configure networking settings later, or else if you want to configure DV switch also, we can configure here. But before configuration, I will explain in the later classes the importance of DV switch, and then we'll try to test it one more time. Okay, so for today's session, I'm just skipping the DV switch configuration. Now click on next. When we click on next, there is a some advanced options. In these advanced options, you can see the vSAN deployment type. The vSAN deployment type, we have multiple types. One is single site cluster and another one is stretched cluster. This is the advanced concept. So at present today's session, we are doing on a single site cluster. Normally stretched cluster we can use only in our organization if we have a remote site or we have a secondary site. During that scenario, we'll configure stretched cluster. The importance of stretched cluster is both data center we can maintain active or active standby data centers. But in our present today's lab, we'll go with a single site cluster, and the remaining features and all, let's leave it blank. Each feature have a one importance functionality. These are all the features and all we can discuss in the at the end of the vSphere concepts. I will explain again, but I quickly give you the what is importance of all these features. Let's say the first option is data at rest encryption. Even our virtual machines, if you want to enable the encryption using vSAN data store, we can enable the encryption mechanism. And data in transit encryption, we have a different types of encryptions. Any encryption method we can use. And the space efficiency, even if you want to set the any of the space, the whatever the space we configuring, if you want to use the additional features like compression, deduplication and compression options, we can use. But for the time being, I'm just going with a none. Reason is our lab systems are normal disks only. If you want to do all these features, we require a actual real SATA hard drives or SAS disks. Okay. And fault domain also for a redundancy purposes, and large scale cluster support. If you click here, you will see large scale how many maximum hosts it supports. It supports up to 64 nodes we can add under vSAN data store. Okay. And RDMA, this is also remote support kind of thing. Let's leave it blank. All the services I'm not configuring in our home lab. Okay. And the host options, lockdown mode, default disable, and NTP server. If you want to enter the NTP server, you can enter, or else we can configure it later as well. And the host update preference, if you want to choose any update mechanism, you can choose. At present, we can choose a no recommendation. Later, we can do all these modifications. And EVC also one of the vCenter feature, enhanced vMotion compatibility. At present, we doesn't require this feature also. Just leave it disable state, and now click on next. And now this is the option. It is showing claim disks. Whatever the disks we configured earlier, each ESXi host we added 3 disks. All these disks you can find here. See, if you read one by one, all the disk model serial number you can find here. The first disk is considered as a capacity tier, and the another disk considered as a cache tier, and all the drive type is considered as a flash. We discuss as a flash and HDD, and architecture also it's a all flash architecture. Suppose if you have a mixed hard disk like SSD disk and HDD disk, we consider as a hybrid drive type and also hybrid architecture. And the disk, how we can add it is 2 disks for 3 hosts, right? Our each host have a 2 disk, and each host 1 disk is dedicated for a cache tier. It's automatically divided by our cluster itself. We haven't decided. It's automatically choose the sizes. If you just expand here, you will find all the disk information. And even the disks also, 2 disks from ESX1, 2 disks from ESX2, and 2 disks from ESX3. Similarly, if you expand the another one, you will find 1 disk from ESX. This is our mode. If you want to change the group also, you can just drop select down menu, choose the host option. You can find host level group also. ESX1, ESX2. Suppose if you see ESX3, you can see every host have 3 hard disks. Within the 3 hard disks, it's automatically set one hard disk as a 30 GB disk as a cache tier, and 50 GB disk is considered as a capacity tier. This same concept only we discussed in the today. What is the disk groups? So we have a 2 types of disk group. One is cache tier, another one is capacity tier. Cache tier is almost similar like a our laptop RAM. It acts like a primary storage memory only. It maintain the buffers. When comes to the capacity tier, it's like a permanent storage. All the data is stored on a capacity tier only. The same information they updated in the top. Total claimed size is 390 GB. Within the 390, vSAN capacity size is 300. That means each ESXi host we added 250s, so that means 100 GB. So 3 ESXi hosts, its equivalent size is 300 GB, and the cache size is 90 GB. So the unclaimed storage is 0%. That means the fully 100% we are going to utilize now. If you want to do any customizations also, we can customize in this wizard, and you can go to the disk mode and you can do the customization, directly expand here, and we can do the customizations here. But for the time being, I'm just using the default option, and we observe the disk status. What is the cache tier and what is the capacity tier? Now let's click on next. And we have an option for proxy settings. This proxy setting will help you to update your data stores whenever there is any latest patches or latest version is available. But for the in our lab, there is no proxy server. Let's leave this as a blank because we do not have a proxy server in our lab. Okay, but in the real-time scenario, if your customer have any specific proxy server, those proxy server details we need to enter here. Okay, now click on next. See the final review. You can just review all the advanced options. The cluster is configured the following option: lockdown mode disable, no NTP, enhance vMotion also disable, host update preference also no recommendation, and RDMA also disable state. These are all the current status. And when come to the vSAN data store, a cluster has vSAN data store, all are in a all flash mechanism. We have a two mechanism, all flash or hybrid. We are using a all flash mechanism now, and cache size is 90 GB, capacity size is 300 GB, and the services, this cluster is configured with a following service, but service default we are using is a vSAN service. Okay, now click on finish. So when we click on finish, in the recent task, you can see the cluster configuration status is running, and also in the configuration cluster, you can see there is a circle is running. So it's a everything automatic method. We no need to do anything manual. It's automatically grouping the disks. It will prepare a vSAN data store ready within the few minutes now. It's just to monitor the recent task status. Just expand the task name. You can find all the description here. See, reconfigure vSAN cluster 75%, and creating the disk group also it's going on, and adding disk to vSAN cluster completed. So it may take a while to finish the status. Once it is finished, when we go to the data store, we can see the vSAN data store will be ready. See, reconfigure vSAN cluster 75% it's completed, and remediation also it's going on. Let's minimize here. Let's minimize recent task here and just observe the status. Even the update vSAN configuration also completed. Let's go to the data store tab. There is some error and warnings. We'll discuss about this. And just go to the data store tab. If you see here, vSAN data store is created and the total size is equivalent to 300 GB. So this 300 GB we added for each host to capacity tier. All the capacity tier disk, it's make it as a total data store size. Okay, this is our data store size. Even if I select each host, go to the data store, you will find a vSAN data store. And the second host, go to data store tab, you can see vSAN data store. Our second host is also connected to NFS as well. And the third data store also, third ESX also connected to vSAN. Okay, so this is how we can configure the vSAN. Let's verify the other error messages. Go to the cluster and go to the configuration tab, select the quick start method. When we select the quick start, the first step is green tick, second step also green tick. When it comes to the third step, it's showing hardware compatibility. There is a hardware compatibility error. The reason is our system is a lab system. It's not a production official server. If you are using official physical box, obviously this hardware compatibility will change to green. So it's a expected behavior. We can safely ignore this error. Okay, again go back to the configure, quick start option, and let's see the another error message. And another error message is online health, because this system is currently not connected to the internet. When we connect to internet, this online health also will become a green. And the network configuration is correct. Physical disks are okay. Data, cluster, capacity utilization, performance service, vSAN build recommendation. See, you can see the terminology. Hyper converged cluster configuration compliance also green tick. So just try to understand this terminology. Hyper converged. Hyper converged is nothing but our hypervisor is converged with the vSAN. Okay, so all the configured host, everything is green. So this is about the vSAN cluster configuration in quick start method. Is it clear? Even the third configuration option also, it's already tick. And if you see the message here, nice work. Your cluster is now successfully configured and ready to run workloads. Ready to run workload means we can create a virtual machines on vSAN data store. In the future, you can add more hosts to your cluster by doing step 2. See, when you click the step 2, you can add option is already highlighted. In future, if you want to add one more host, just click on add and you can enter your ESXi host IP, username and password, and you can add not only one host, you can add multiple hosts here. Okay, the maximum how many hosts we can add within the vSAN cluster?
16.
We can add maximum 64 ESXi hosts. So today we mentioned in our first diagram, the minimum host for the vSAN cluster is 3 ESXi hosts and maximum we can add 64 ESXi hosts. Okay, so let's back to our lab slide. In our lab slide, the first point we already done, vSAN cluster setup ready, and create cluster we did for a quick start method. Now we can do for a manual method. How we can configure in a manual method. Okay, for manual method, let's log into the vCenter. Even if you want to use the same vCenter also, we can use. Let's say log into the workstation again and right click the ESXi host. Now I'm just adding a again additional hard disk, but this time we can change the disk sizes so it's easy for us to understand. Instead of 30 GB, I'm just adding a 15 GB hard disk. 15 GB hard disk for cache tier, and I'm going to add a 260s for capacity tier. So 60, click on next, next. So 60 GB is added, and similarly you can add another 60. 60 GB, click on next and finish. So click on OK. So when we add the additional disk, it requires a restart. So quickly restart the ESXi host. And the same way, we can add the additional disks for ESX2. So for cache tier, let's add 15 GB. Click on next and add another 260s. 60 GB and one more 60. Click on OK. So 3 hard disks are added. Go to the power, restart guest to apply the changes. And the same way, ESX3, add hard disk. And now we can add 15 GB for cache tier and another 60 GB for capacity tier. 60 and one more 60. 60, click on next and finish. So we already added the 3 hard disks for ESX3 also. Quickly restart. Okay, so we added 3 hard disk again. Now this time we can going to configure vSAN cluster using manual method. ESX1 already up and ESX2 rebooting and ESX3 also rebooting. So in the meantime, once these 3 hosts are up, I will just show you where we can see the manual method option. Log into our vCenter server. Go to the cluster, configure. Under configuration tab, just scroll down. You can see the separate option for vSAN. Under vSAN, you can see the option for services. When you go to the services also, we have an option to add virtual SAN. But here we already added a vSAN services. Now we are going to configure a additional vSAN data store. 2 hosts are reboot in progress. That's why it is showing the non-compliant warning. It will be cleared once these 2 hosts are up. See in the right side option, you can see turn off virtual SAN. Even if you want to enable the virtual SAN manual method, come to the services section under vSAN. So go to the services section. Right side, you can see the vSAN on option. Okay, this is a manual method. And the quick start method is we no need to do anything. Everything is taken care by this wizard. It will do 3 steps. Cluster basics, add host, configure host. See, configure host again become a error. Reason is we restarted one host. That's why it's changed the status to error. Once the ESX3 is up, the error will become a green. Let's wait for the ESX3. Then we can go to the services section and we'll configure. Let's monitor from workstation screen. ESX3, yeah, still loading. ESX1, ESX2 both are up. Only ESX3 is booting. Okay, ESX3 also up. Now log into the vCenter server. In our summary tab, there is some alarms, so it's a safely ignore. We manually restarted. That's why we are getting the error messages. Even if you see in the recent task, our vSAN configuration is automatically updating. Go to the data configure tab, quick start. Now the configure host step is become a normal. Earlier it was a critical state. Now it become back to normal state. Normal state means color is green. And now the manual method come to the vSAN services tab. Under services, you can see even the performance service all are healthy state now. Even the turn off SAN, we no need to turn off vSAN. We require to enable. It's already in a enable state. And if you want to create a additional data store to our vCenter for manual method, in the below of the services, I'm just showing you how to enable in the manual method. This is the option to enable a vSAN. Currently, when I click turn off, it will turn off, but it's already in a turn on state. This is the way we can turn on in the manual method. And once we enable the vSAN option, and we can come to the disk management. So the two methods are during the cluster quick start method also you can enable vSAN, and another option is under services section you can enable the vSAN. And then second step is come to the disk management. It's loading the disks. See here you can see the current available disks, and if you see here the view the cluster objects. The current cluster objects is one data store is already created. Let's back here. Back to the host list. Under host list, you can see view disks also. You can see the view disks are already added 3 disks, and there is a unclaimed disks. These unclaimed disks only we are going to configure now 60, 60 and 15. Okay, so how we can configure is here there is an option to create a disk group. So this is the manual method to configure a disk group. So click on disk group. When we click on disk group, you can see the options for flash. All the flash are showing as 15 GB, 60 and 60. And also select a single site cache tier and also the capacity tier. Here it's saying that select a single disk for cache tier. So I'm selecting a 15, and also here it is saying that select one or more disks for capacity tier. So select the 2 disks for capacity tier. Okay, so now click on create. This is selected for a ESX1, similarly for ESX2. And here the host also selected as ESX1. Now select the ESX2. When we select the ESX2, again click on disk group and cache tier, we need to choose one hard disk, and for the capacity tier, choose the 260 hard disk, click on create. And similarly, ESX2, you can also choose ESX3. When we select the ESX3 also, there is a unclaimed disks. Unclaimed disk, we can create a disk group. So for cache tier, select the 15 GB, and for the capacity tier, select the 60 GB hard disk, click on create. This is the manual method of creation. So if you see the recent task, the disk creations are in progress. Add disk to vSAN cluster. Create disk to vSAN. So still the creation is in progress. In the meantime, we'll select the ESXi host and observe. But currently in this scenario, it's manually added to the same data store. It's not created as a new data store. Okay. So earlier it was a 300 GB. Now we manually added some more additional disk. All the disk we can group and we combined under the same data store. You can combine under the same data store, or you can split into the new data store also. Go to the configuration tab, select the cluster, go to the configure tab. Under the disk group, we can do modify, and also we can see do the modifications from here as well. View the cluster objects. Currently it's already added. And the fault domain is the one of the latest option. This is for a mainly for the failover and redundancy purposes. To maintain the fault domain option, it clearly says that drag and drop your action menu. So if you want to add to the fault domain, just drag here. This is like a primary site. So for example, fault domain site 1. Click on create. And similarly, if you want to create the fault domain for another one also, just drag and drop. This all comes under the same site because we do not have a secondary site. When you have a secondary site, you can add drag and drop in another site. So this is during the stretch cluster scenario, we can configure another site. During that time, I will explain this concept. Okay, how to configure a stretched cluster. Okay, so this is how we can create a vSAN cluster in the manual method. Still the some of the backend update configuration is going on. That's why we are seeing the error messages. So when we wait for some time, all the status will be update and the status will be changed to green. Okay, so let's back to our lab slide. So the first point we already completed, and the cluster and enable vSAN we did for a quick start method as well as manual method also we updated the vSAN data store and validate vSAN data store configuration. So if you want to validate vSAN data store configuration, go to the storage tab and select the vSAN data store and come to the summary tab. You can see all the validation information. You can see vSAN usages. We have totally 659 GB and 11 GB only used. And also if you expand the details, you can see this is the location and the type is vSAN. How many hosts? We have 3 hosts and related objects, nothing. And this is the summary tab. We have the health status and what is the capacity used. All the information you can find here. And the monitor tab, you can find the monitoring, any task you perform on the vSAN, those information you can find here. Okay, and the capacity information also under the monitor stage. Here you can see the capacity overview, how much is used, and even the usable breakdown also you can find here. Total usable space, all the information you can find from the monitor capacities tab. Okay, and if any volumes we have, we can see the volumes here, but currently we haven't created any container volumes. And come to the configuration tab, you can see again all the configuration information. Okay, and hardware acceleration. If you want to schedule any task, we can schedule here. And if we want to set the permissions for the vSAN data store, we can set the permissions using permissions tab. And the files, if you create any virtual machines, you can find the virtual machines. Present there is no virtual machine, we can create a new virtual machine now. Right click here, new virtual machine. We are going to create on a vSAN data store. Let's say vSAN test VM, vSAN test VM01, and click on next. And we can choose any one ESXi host, click on next, and data store we are choosing as a vSAN data store. And the policies also, if you want to modify the policy, you can choose vSAN default storage policy. That means in case of one hard disk is down, still our vSAN will support for a RAID 1 mode, the mirroring. If any hard disk failed also, there will be no impact to our virtual machine. This is how we can choose the default storage policy. It says that data store doesn't match the current VM policy because we do not have a RAID controller card. So that's why we are getting this warning message, but it's safe to ignore this warning. Click on next. And we can use the ESXi host compatibility next and choose the guest OS, let's say 2019, click on next. And if you want to customize the hardware, we can customize the hardware. And we send default policy also. If you want to modify anything, we can modify here from the VM customization screen. And any additional options, if you want to change the network adapter type, you can change to VMX Net 3. And the remaining settings, we can leave it as it is and click on next. Click on finish. So create virtual machine cannot complete. Maybe it's due to we selected the policy. We do not have a RAID controller card. So we can ignore the policy and create a virtual machine. New virtual machine. I'm just going with the default options this time. Click next. So we'll go with the data store default. Next, 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 finish. Again, error. That means some configuration is still going on. Yeah, update recommended vSAN baseline group is in progress. But the VM creation is pretty simple as how we created on the FCSAN, iSCSI SAN and NFC. The VMs on a virtual SAN also. Okay, so if you see the lab, we observed the validate the vSAN data store configuration we observed, and health status we verified from the when we select the vSAN cluster monitor tab and verify virtual machine on vSAN data. So we created the VM, but due to RAID controller, we do not have RAID controller. That is why it's giving a message. Configurations are still going on. It may take some time to finish. So we verified all these vSAN labs. If you have any questions, let me know. That's it for today. If no questions, we can end the session here. Thanks for your time.
Thank you, sir.
Thank you. Thank you.
Thank you.
Yeah, bye for now.